2.8 proofs about angles, and here is our first proof. So reason 1, statement 1 are given. Step number 2, we're going to convert that from congruent into equal, and that's the definition of congruent angles. Now I'm going to look at the proof statement. I want two angles together that add up to angle CBD, and on the drawing I notice that 1 and 3 are actually the two angles that do that. So using the angle addition postulate, you can say that 1 plus 3 equals CBD. So I'm close to having my proof statement. And as I look at the drawing, angle 1 is equal to angle 2. That would be the vertical angle theorem. Now, I can take out angle 1 and plug 2 in for it. Likewise, because of what we have in step number 2, I can take out 3 and plug 4 in for it. And that would be a substitution. A substitution of step 3 because that's the equation I was using. Step number 4 because that's where I knew that angle 1 equals angle 2. And step 2, that's where I knew that 3 equals 4. And now I have what I was trying to prove, so that proof is over. Number 2, step 1 given. Step number 2, 1 equals 2 because of the given, that is the definition of angle bisector. And 1 and 4 are vertical angles, 2 and 3 are vertical angles. So using the vertical angle theorem, they're equal to each other. So then I'm trying to get 3 equal to 4. 3 equals 2, 2 equals 1, 1 equals 4. That would be a transitive to say that 3 equals 4. Number 3, a little bit longer here. First off, we have the given. And then step number 2, we're going to convert these congruent angles into equal angles. Again, so they're usable. That's the definition of congruent angles. The statement has something about 5 and 6 equaling 7 and 9. And so to consider that part of the proof statement, I notice that 5 and 6 form a linear pair. They add up to 180. I'm going to use that to my advantage. In step number 3, this is going to be the linear pair postulate to say 5 and 6 are supplements. You can see that on here. Also, we can say that 7 and 8 are supplements because they form a linear pair. Linear pair means supplements. Supplements gets us to 180 degrees. So number 4, we're going to say that's definition of supplements. I'm taking this statement about 5 and 6 and turning it into an equation. So 5 plus 6 equals 180, 7 plus 8 equals 180, which allows us in step number 5 then to say that the sum of 5 plus 6 equals the sum of 7 plus 8. That would be a transitive. And then, since 8 equals 9, we can take 8 out and plug 9 in for it. I see that up here in step number 2. That would be a substitution of steps 5 and 2, and that's what we're trying to prove. Here's the fourth one. Lots of given, and I have those markings on there already. We're trying to prove that 6 plus 1 equals 2 plus 3. And I notice again that 2 and 3 form a linear pair, so they're going to be supplements. Looking at the proof statement on there. We'll say 2 and 3 are supplements, linear pair postulate. And then, thinking about the given, 1 and 6 are nowhere near each other, but these angles 4 and 5 form a linear pair. So we're going to say that they're supplements as well because of the linear pair postulate. Taking step 2 into step 3, since 4 and 5 are supplements, they add up to 180. 2 and 3 also add up to 180. That is the essence of supplements. It's a definition of supplements for our reason then. With a transitive, 4 plus 5 is equal to 2 plus 3. Since they both add up to 180, those sums are equal to each other. Again, it's just a transitive. And then a substitution. We can take out 4 and plug in 6, take out 5 and plug in 1 because we're given that they're equal to each other. And this is the statement that we want. Number 5. Lots of given information. We're trying to get angle 4 congruent to angle 1, and there's no real connection to them right away. But looking at this given, I'm trying to find some statements or equations that deal with these angles as well as those angles. And I notice that 6 and 2 are supplements to each other, as well as 3 and 4. That would be because of the linear pair postulate. If I convert this congruent into equal, that'll take up one step. That's the definition of congruent angles. So now that they're usable. And from this yellow equation I have highlighted to this one, since 1 is equal to 2, and 3 is equal to 6, we can make a substitution. So I'm taking 6 out and plugging 3 in for it, taking this 2 out and plugging 1 in for it, So I can see that 3 and 1 are supplements. And then using the congruent supplements theorem, since angle 4 is supplementary to 3 and angle 1 is supplementary to 3, congruent supplements theorems allows it to say that 4 is congruent to 1. It's a nice shortcut reason. You could do it in some other ways, but that's going to be the quickest way to make that happen. Here's number 6. So we're given that angle 1 is congruent to angle 3. Step number 2, converting them into equal. That's the definition of congruent angles. Then we have angle addition postulate. 1 and 2 make up RNT. 3 and 2 make up SNP. And then we're going to take this statement and alter it a little bit. Since 3 is equal to 1, we're going to plug 1 in for 3 to get this statement. And now I see that RNT is equal to 1 plus 2. 1 plus 2 is also equal to SNP. So by the transitive property, these two are equal to each other. And then definition of congruent angles, we get them to congruent because that's what we're trying to prove. And number 7, we have the measure of angle PNA is equal to measure of angle KNT. So now these overlapping angles are equal to each other. Trying to prove that 4 equals 6. So combining the given and the proof statement, it gives me an idea of how to start. I want an equation that relates these things with each other. So I notice on the drawing that 4 and 5 make up PNA. 6 and 5 make up KNT. So angle addition postulate for number 2. And since PNA is equal to KNT from the given, I can say that this expression is equal to that expression, and that's a transitive. The goal is to get 4 equal to 6, and I notice that 5 is on both sides, so in step 4 we'll say 5 equals 5 reflexive, so that in the final step we can subtract 5 off of the left, subtract 5 off of the right, leaving us with measure of 4 equals measure of 6. It would be a subtraction of 3 and 4.